All right, welcome ladies and gentlemen. This is our second video in the organic chemistry unit on alkenes and alkynes. So make sure you have your notes out. And in addition, please make sure you have your reference tables, because I will be referring to specifically table Q. So please grab that and have a look at that. Now this video is starting on page 6 in our notes, I believe, alkenes and alkynes. Before I even go to the next slide, I want to point out that we're talking about things called alkenes and alkynes. Notice that we have a different suffix instead of alkanes. The suffix in alkane indicated that we had single bonds, all single bonds in our carbon chain. We have changed that suffix, which will indicate that we no longer have all single bonds. So in discussing alkenes and alkynes, and if you have a look at table Q, you can see in the structural formulas that we do have different types of bonding now. So first up, alkene. An alkene is a hydrocarbon. Well, I knew that already because it has that alk prefix, which means hydrocarbon, with at least one double bond in between the carbons. So this ene prefix, this new suffix, indicates the presence of a double bond instead of just having all single bonds in the carbon chain. Key thing here is that we don't need it to be all double bonded. In fact, we're never going to see something that's just nothing but double bonded carbons. You only need to have one double bond in a chain of, let's say, even like 150 plus carbons in order for it to be considered an alkene. So just one double bond, that's really all we need. That's all we're going to see. And again, important point. New suffix, ene suffix, means that we have a double bond. If you look at table Q, we have the general formula for an alkene, which is CnH2n. So for example, if we had a chain that had 4 carbons, well, the 4, because it's the carbon, that would be the N value. So we simply follow the formula. If we double 4, we get 8. So that's the number of hydrogens that we would have with an alkene. That's the pattern for the alkene. So the formula for an alkene is for this alkene would be C4H8. Notice that there are fewer hydrogens than an ane. Right? Fewer hydrogens in this general formula. That's because the carbon is bonding more frequently with itself because it's got a double bond. So it's bonding twice with carbon, twice with itself. So it can't bond as much with hydrogens. We're going to have fewer hydrogens on this compound. And again, we have the ene suffix. So the example of an alkene shown here on the bottom, this compound is called ethene. Because this compound contains 2 carbons, and ene because we have this double bond that's connecting the 2 carbons. Notice that each carbon here has 4 bonds, so you're always being very, very careful here. We look at this number 1 carbon, we have 1, 2, 3, and 4. Every carbon always gets 4 bonds, so we're always very, very, very mindful of that. An alkyne is a hydrocarbon, but I knew that already because the alk prefix means hydrocarbon. But then we have this ine suffix, so a hydrocarbon with at least 1 triple bond. So this ine suffix, changing the type of bonding, we have a triple bond between the carbons. Again, you only need 1 triple bond. You can have other carbons that are single bonded, but then if you have 1 carbon in the chain that's triple bonded to another carbon, then you know you have an alkyne. So this ine suffix, change the suffix, change the type of bonding. That is a triple bond. Again, in table Q, the general formula is CnH2n minus 2. So if we go back to our 4 carbon example from the previous one, if we had 4 carbons in the compound and it was an alkyne, well, the number 4, that would be the N value, the number of carbons. So double it, 2N, that would be 8, but then subtract 2, so that would be 6. So following the formula, I'd have 6 hydrogens in an alkyne. So that would be C4H6. Again, notice fewer carbons than ane or ene, because the carbon is bonding more frequently with itself. It's bonding more to other carbons, so it can't bond as many times with hydrogens. So we have that ine suffix, and then our example shown here on the bottom, this compound is called ethyne. It's called ethyne because the compound has 2 carbons, so eth meaning 2 carbons. And it's called -ine, it ends in -ine because we have the triple bond. So ethyne, 2 carbons connected via a triple bond. Again, notice every carbon has 4 bonds. So this first carbon here, it's got 1 bond here, but then 2, 3, 4 to itself. So it can't bond that many times with hydrogen. Naming alkenes and alkynes. It's very, very similar to naming alkanes. There's just a few small differences that I'm going to go over. So the first thing that you want to do is, it says step 1, name the parent compound. Find the longest chain that contains a double or a triple bond and name that based on the number of carbons and our suffixes for bonding. So the key thing here is find the longest chain that contains the double or the triple bond. The double or the triple bond will never, ever, ever be the substituent. So you always have to make sure you include that into your longest possible carbon chain. So for example, this compound here, this is the longest carbon chain. There are actually no substituents. We're going to see that later. And simply count it up. So I got 1, 2, 3, 4, 5, 6 carbons. Okay, so I have 6 carbons. So 6 carbons, the prefix there is hex. And then I have to figure out which suffix I'm going to use. Well, I notice right here I have a double bond. So the suffix that I'm going to use, the suffix that indicates double bond, is -ine. So I have a 6 carbon chain that has a double bond in it. So I'm going to put it together into my base name, into my parent name, and that's going to be hexene. 6 carbons containing a double bond, hexene. But I'm not actually done, even though I don't have any substituents, because I still have to number the carbon chain. Because I have to say where that double bond is, because that double bond could be many different locations in this carbon chain, because there's only one of them. So I have to number the chain. And how I number the chain, if I don't have any substituents, is that we want the double bond to be closest to the number 1 carbon. Basically, you want your double bond or your triple bond to be closest to the number 1 carbon. And the way we use the number system here is the number will indicate at which carbon your multiple bond starts. So at which carbon in the chain does the double or the triple bond begin at? That's the number that we're paying attention to. Where does the double or the triple bond start? Now, this is also very important. If you have both double bonds and a substituent, your double bond is actually more important than your substituent in numbering your chain. It sort of dictates how the chain will get numbered. It's more important. So if we look at this example, this is our hexene example. You always have 2 options for numbering your chain, left to right or right to left. So if I number it left to right, this would be 1, 2, 3, 4, 5, 6. But then if I do right to left, we'd have 1, 2, 3, 4, 5, 6. And the way I know which one is correct is by looking at the double bond. If I look at the double bond, which is here, the left to right, the double bond starts on the number 4 carbon. But if I number it right to left, then the double bond starts here. It starts on the number 2 carbon. We want the multiple bond to start on the lowest possible numbered carbon. So that's going to mean that left to right is wrong. And in this case, right to left is correct. So I'm going to number this chain right to left because it gives my double bond on the lowest numbered possible carbon. And I'm only going to use 1 number in my name. I'm not going to say that it's 2, 3 hexene. Instead, I'm simply going to give the number of the carbon that it starts at. So it shows here. So if the double bond, like it says, is between the 2 and the 3 carbon, then I would use the number 2 in the name. So assembling this entire name together, we have this compound which contains 6 carbons. So I use the hex prefix. This compound also contains a double bond here, so I use the -ine suffix. But then I had to number the chain 1, 2, 3, 4, 5, 6. So that the double bond was closest to the number 2 carbon. So the number that I use is 2. So I would say this compound is named 2-hexene. The 2 out in front telling me that the -ine starts at the number 2 carbon. That's what that number is saying. So just practicing a little bit and looking at an alkyne as well, if we want to name these compounds using the same system. So this first one here, well, there are 4 carbons, right? 1, 2, 3, 4. So the prefix for that is bute. And I have a double bond, so the suffix for that is -ene. But then I have to number my carbon chains so that the double bond or the triple bond is closest to the number 1 carbon. So in this case, that's left to right, 1, 2, 3, 4. And the number I'm going to put out in front of this is where it starts, and it starts at the number 1 carbon. So this compound is 1-butene. This next compound also contains 4 carbons, so it has the bute prefix. It also contains a double bond, so it will also have the -ene suffix. But now, notice that the carbon chain starts at the number 2 carbon. Now I could number this left to right. I could also number this right to left. In both cases, the double bond starts at the number 2 carbon, so I know that this is 2-butene regardless of the direction that I'm numbering it. This next compound also contains 4 carbons, so the prefix is bute. It also contains a double bond, so the suffix is -ene. Numbering this, I have 2 options. I could go left to right, 1, 2, 3, 4, or I could do right to left, 1, 2, 3, 4. And notice when I go right to left that is the way that's going to work. I'm not going to keep this 1. I'm going to use the right to left because it has my double bond starting on the lowest possible carbon. These 2 compounds are actually the exact same compound. They absolutely are. Now this last one, it also has 4 carbons, so its prefix is bute, but we have a triple bond instead of a double bond. So I'm going to use my triple bond prefix, my -ine prefix instead. And numbering the carbon chain so that the triple bond is closest to the number 1 carbon, I could go right to left, in which case it would start on the number 2 carbon, or I could go left to right, 1, 2, 3, 4, in which case it would still start on the number 2 carbon, so this is 2-butene. For drawing alkenes and alkynes, biggest thing is to basically start at the back and work your way forward and ensure that that carbon gets 4 bonds all the time. So 3-nonine, pulling this name apart, what does non mean? Non means 9 carbons. What does ine mean? Ine means that I have a triple bond. What is the 3 telling me? It's telling me where the triple bond is. So drawing that, I'm going to start with a 9 carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I do start by connecting them with single bonds, but then I'm going to go in and I'm going to add my triple bond. So where am I going to put it? I have to start at the 1, 2, 3rd carbon and give it a triple bond to the 4th carbon. So it starts out the 3rd carbon and then simply go back and give each carbon 4 bonds. So this first carbon needs 3 more bonds to get to 4. The second carbon needs 2 more bonds to get to 4. Ooh, this 3rd carbon is actually completely set. It already has 4 bonds. So don't draw any more hydrogens there. As does the 4th carbon. It already has 4 bonds. But this guy needs 2, that guy needs 2, that guy needs 2, and this last guy needs 3. So every carbon always gets 4 bonds. Be very careful about that. 2-heptene. What is, if I want to draw this, what is this name telling me? Well, hept is telling me 7 carbons. Ene is telling me that I have a double bond. And the 2 is telling me where the double bond is. So I'm going to start by drawing a 7 carbon chain. 1, 2, 3, 4, 5, 6, 7. I was just starting with double bonds, single bonds, but I know I'm going to go in and add a double bond. Where am I going to add it? I'm going to add it at the 2nd carbon in, between the 2nd and the 3rd carbon. So I'm going to give that 2nd carbon a double bond to the 3rd carbon, and then go back and tell me number of hydrogens, basically give each carbon 4 bonds. So this first carbon needs an additional 3. This 2nd carbon already has 3 bonds, a single and a double, so it only needs 1 more. Likewise, the 3rd carbon only needs 1 more because it already has 3 bonds. But this next guy needs 2 more to get to 4, 2 more to get to 4, 2 more to get to 4, 3 more to get to 4. Naming alkenes and alkynes with substituents. It's literally the exact same process. Start with your base name, build your way forward. So this compound right here, we want to start by finding the longest carbon chain. Longest carbon chain is right here. And then we want to name that, just like we did with alkenes and alkynes. So I have 1, 2, 3, 4, 5, 6, 7 carbons. So 7 carbons, that means I'm going to use the hept prefix. I do have a double bond, so I'm going to use the -ene suffix, and I have to number my carbon chain first, not paying attention to the substituents yet, so that my double bond is closest to the number 1 carbon. So that's going to be left to right in this case. So this is going to be 1, 2, 3, 4, 5, 6, 7. So starting to build my name, this is going to be heptene at the end for that base name, but I have to put a 2 out in front, 2-heptene, to indicate that the -ene is starting at the number 2 carbon. So that's naming the base name first. We then have to name the substituents and say where they are. So now that I've named the base name, I'm going to go back and I'm going to think about the substituents. So I have an F. That's called a fluoro. Remember, our halo groups, our halogens, end in O. But remember, you have to also say where it is. Now, you're not renumbering your carbon chain. You already did that. So you have to keep with the numbers that you did the first time around. So I've already figured out that this is the number 1 carbon. So this is going to be 1-fluoro. That's the name of that compound. This is also a substituent. This is 1 carbon. So this is going to be a methyl group. Remember, meth means 1 carbon, il means substituent. So a 1 carbon substituent is a methyl group. But you have to say where it is. It is on the number 5 carbon, so I'm going to stick a 5 out in front of that. So that is 5-methyl. And then you simply take these names of these substituents and you put them right out in front of your base name here, the 2 heptenes. So I'm going to say 1-fluoro 5-methyl 2-heptene. That's the name of that compound. It sounds crazy, but it's just ridiculously descriptive. That's all it's doing. It's just describing the compound. And then one example with drawing with substituents, 2-methyl-1-propene. Whenever you're asked to draw, start at the end. I'm going to worry about the substituents later. I'm going to start at the end. So looking at the end of this, prop means 3 carbons. Ene means double bond. This is telling me where the double bond is. So I'm going to draw 1, 2, 3 carbons with the double bond between the number 1 and the number 2 carbon. Right? So that takes care of the 1-propene. Then I'm going to look out in front. Methyl. Well, meth means 1 carbon. The YL means that it's a substituent. So I know I'm going to be drawing a 1 carbon substituent to this main chain, but I have to know where to put it. So this out in front is telling me the location. So it's telling me that off of the number 2 carbon, I have a 1 carbon chain, a methyl group. And that's my compound, but I'm not done because I have to give it number of hydrogens. Each carbon needs 4 bonds. So this first carbon here that's on the left, it already has 2 bonds, so it only needs 2 more. This carbon that's in the middle, look at it, actually already has 4 bonds. It's got a double bond and 2 single bonds, so it's set. Do not forget about your substituents, right? They need 4 bonds too. Don't leave them hanging. And then our last carbon on the end only has 1 bond, so we need to give it 3 more. So tomorrow you'll be practicing naming and drawing alkenes and alkynes, also with pen and paper and with the model kit.